Hello again and Happy New Year, belated Happy New Year. It's New Year's Eve and I'm back in the workshop again. This is going to be what I expect to be quite an exciting little video. There's a couple of things I need to do, but before I do that, let me just bring you up to speed with where I believe I've got to at the moment. And I'm going to wave my hands around to explain what I'm thinking about. First of all, you have the gearbox. You have a bearing pushed in till it's located for the lay shaft. And then on the other end of the lay shaft, you have the kickstarter housing. And the lay shaft, in effect, is controlled with the end float and everything by the kickstarter housing. Above that, you have the main shaft. And you have the sleeve gear and its oil thrower that's pushed through the bearing. That's then secured with all the screw-on clutch attachments, so that's locked in place. The main shaft goes through that and locates in a bearing in the end cover, and that's tightened down and located with a nut. So what I need to try and establish is where these things are relative to one another, and also where they are to the pivot that the cam plate sits on, because the cam plate of course dictates where the selector forks are, and that means that where the sliding dogs are, whether they move left or right and so on. So I just need to make sure that everything is, roughly speaking, where it should be, and that's all going to take place while the gearbox is in the vise. And the only problem is it may prove to be very difficult for me to do this and have you looking at this, because my head and hands are certainly going to be in the way. There's an additional issue that has to be confronted, given that the main shaft is secured in the cover, and the cover and its nut is going to be taken away so that I can get access to that. This main shaft can move around. So there's a very simple contraption which you can apply to the gearbox, which means that you know exactly where the main shaft is located, because that means that you know where all the circlips are and all the various gears which are located by the circlips. So, and you know where the position of those gears are relative to the sleeve gear, which is locked into the bearing. Remember that bearing was located with a ring and peened in. So a little bit more to that. Let me just turn the camera around. Right, just to start with, this is just a piece of 8mm studding, 2 nuts clamped into the top gearbox housing, and a piece of offcut, just a piece of junk over here, which has got a hole in it with 2 nuts, and that also is able to slide. While this is mounted solidly, this thing can be adjusted. And what you need to do is just take a feeler gauge. You need, to my mind, have a little bit of a gap between down here, so that you don't have a sense that you are adjusting this to the point where it's bending. You need this just to be sitting there, and the way to establish that is just use a feeler gauge. That just feels nice. That's 1.5. Well, I've just measured this feeler gauge. It's meant to be 1.5 thou, but it's actually 2 thou thick. So I went through the rest of the feeler gauges, and they're all pretty good, apart from the 8 thou, which is 8.5 thou thick. Now these things are meant to be accurate. So anyway, the key point is that you set the end float here, and what that means then is that when this nut over here is removed and the gearbox cover is removed, then that main shaft can be put back into its proper location. And I'm just removing this nut, and hopefully this will all just pull away now. I have a mag base now mounted on a square slab of steel, which is very useful. I'm able to prop this up on top of the Velocette engine when I'm checking valve timing and stuff like that. So having a good solid lump of metal that the mag base will stick to is very convenient. Now what you can see here is the dial gauge up against this gear. I've put a spare bearing on here, an old bearing, tightened down with the nut. This bearing should be in the cover, but this is just an old one, and it will enable me to check the end float between this gear and the bearing. But before I start playing around with this, I just need to make sure that the main shaft is in the right position by getting my trusty incorrect feeler gauge Okay, that's a nice feel. So let me just set this at 0. And let me just pull this out now and see how much. That's about, I think that's 10 thou, or 9 thou. We'll call that 9 thou. This, yeah, I'm happy with 9 thou. Right, I've got this gear I've removed this gear. And I put the indicator onto the selector fork. And I just want to see how much movement there is in that in terms of slack. So that's, hang on, that's pushed in. And now if I pull it out, let me put that round to 0 again. It looks like that's at 0, and that's about 17 thou. Okay, that's worth remembering. I'll note that that's an unworn selector fork in an unworn selector plate in neutral. Now, as you can see, this selector fork moves outwards to engage with this gear here, and I just want to make sure that when it comes out fully, it doesn't take up some of the end float of this gear here. I just want to make sure that everything is comfortable. So if I put that on there, swing the dial gauge around, I'm really just looking for no movement on the dial gauge. Right. Well, yeah, virtually there is no movement. If anything, it takes the dogs right into the hole, into the recess, and there's still a little bit of end float. That's all I can ask for. I think you get the picture now. What I need to do is make sure that whenever a gear engages, it fully withdraws before the next gear is engaged. Otherwise, there's going to be something, there'll be a crash, and something dreadful is going to happen. The worst case is that the gearbox is going to lock up. Now, I have to put my faith in Quaife. They've probably scratched their head and they've done a lot of design verification, and the chances are, with casting this machine properly, all of this is going to work. I'm pretty confident, but I'm still being cautious, and I'm still just going through the motions to make sure that everything is okay, because I can still add shims. I can make a little bit of room, I can take a little bit of room away, and that also applies to the shims on the lay shaft. I've pushed that lay shaft in, and I've controlled it with end float, but I could actually shim the lay shaft out ever so slightly. There is a little bit of adjustment. It's probably going to drive me mad, but I'm going to go through it all very carefully. As you can see, the sleeve gear can move in and out. Now, it's not secured in the bearing, but when the time comes for you to push put all the clutch parts on and engage in these threads, very often what happens is the sleeve gear just gets pushed into the gearbox unless you engage top gear. Let me just show you what happens when I'm in 4th gear now, and I've twiddled this around so that the sliding dogs engage in the appropriate holds. But if I just change into top gear, you'll see what happens. Right, as you can see, I've put a vice grip here on the nut, and I've stopped the main shaft turning. This is 1st gear, this is neutral, and this is 2nd gear. So what this means is, essentially, between 1st gear and 2nd gear, there's a neutral position. That's duplicated throughout all of the gear positions on the cam plate. And while this one has a detente to make sure that you stay or it can engage neutral, I've very carefully applied this old bar that I've been using, and I've rotated the selector plate to half positions just to confirm that there is always a neutral between one gear and the next gear, and that just confirms that there's not going to be any sort of a crash. The other thing which I've done, let me just move the camera so slightly, I've decided to eliminate some of the end float on this bush. I had it about 22, 23 thou, but I've added some steel shims in there now, which means the thrust pad will limit the lay shaft movement to about 2 thou, and I've got about 3 thou clearance on this bush. So everything is free to move, there's no bindings, and this means that the Kickstarter shaft can't move, and even the gears behind it up to the inboard circlip. Right, I'll just give you an example of what I mean by this halfway position. There's top gear. As you can see, the sleeve gear is locked to the other gear, so the dogs are hitting. So if I start to change gear now into fourth gear, there's neutral, and then if I keep going down another little bit, there, now I'm in locked in fourth gear. And if I head back towards fifth gear again, I've got a, hang on, let me just engage this bar again. Right, there's neutral, and then I keep going, and then I'm in top gear. So that's the neutral check to make sure there's no crashes. And that little check on finding a neutral position between each gear, it's easily done. It's just a duplicate of what I've shown you in the test between fourth gear and fifth gear and so on. Well, that's it. Hopefully those gears aren't going to see the light of day for a long time. In preparation for bringing this to the lathe, I put the cover on. This nut has been tightened. I've also put a cable tie here to stop the Kickstarter from sliding inwards once it comes off this ramp. My reason for that is I'm pretty sure I'm going to have to position this in that somewhere like that to make this work on the lathe. I've just tried my normal rotating center, and that's not going to work. So I'll have to put a fixed or a non-rotating center in, and I'll just put a dollop of MS3 grease on that, and then we're getting close, folks. Well, as you can see, I've got the gearbox now mounted in the lathe. I forgot to turn the camera on when I was loading it up. As you can see, there's a hard center picked up on the center hole, which was machined by Quaife into the main shaft, and that's now supporting that. And the other end is over here, where I've got a nut in the chuck, and I've also put an old clutch part on with a cable tie, and that will stop the sleeve gear migrating in and causing problems when I'm going through this. So I'm just going to reposition the camera and let's see what happens. Right, this is the moment I've been waiting for. Clutch lifted, motor on. I think it's in top gear now. Let me let the clutch out a little bit. No, that's first gear. Second, third, fourth, there's fifth gear. So to go down through the gears again, fourth, it's in top now, there's fourth, third, second, first. Right, I'm very happy with the way this has worked out. The gearbox is functioning perfectly, it's selecting gears. The temperature, I've just checked that. At the moment the temperature here is 0 degrees. So everything is still turning, and that means that even though this aluminium will undoubtedly have shrunk as much as it's going to, everything is still free to turn despite the tight clearances I put on everything. So that's a success. There'll be a slight delay now between where we are now and putting it in the bike. I have a little distraction on the lathe, which I'm going to enjoy, and I might even include this in the in this video. What I've got to do is set up for some metric thread cutting. That involves changing these gears. There's a kit to convert this, this is an imperial lathe, and this is normally the way for changing pitch when machining or indeed cutting threads. So there's another little table in there, and a kit which will enable me to cut metric threads. I have to come up with something for a friend of mine who is trying to produce, who wants to produce a little tube which will screw in instead of a dipstick, and that will enable us to take a little tap off this and run a pressure pump or a diaphragm type pump which works off pressure fluctuations. The engine itself is a 400cc single. It's an industrial engine, and for one reason or another it needs to have a pumped supply of fuel to the carb and back to the tank. Anyway, look, let's leave it at that. This has all turned out to be what I would call a success. I'm lucky to have managed to get this to fit on the lathe. It just about works, and that's it. Stand by for another bulletin on this distraction. It's time for some knurling now. As you can see, this is just a tool with some wheels on it which have a pattern, and in effect this is not metal cutting so much as metal deformation. This tool has got several different pitches of wheel or pattern. I'm going to use these coarse ones. This is a brutal process. As I said, it's metal deformation rather than metal cutting, and I've got to feed the loads into the lathe gently. So all this needs to be done slowly and carefully with lots of oil. Right, I just need to knurl this on the top part so that people can get at this. Fortunately, this little engine has got 2 dipsticks. This just gives you an idea of what the first pass has generated. This just gives you a view of the finished knurling. All of those little deformations all look fairly uniform, and I'm not sure if this will focus adequately if I bring it in much closer, but you get the picture. Well, the secret to this conversion to metric rather is to follow the little the table on the back of this little gear cover. This is the conversion kit. I've got some instructions, and when I got this, first of all, I couldn't make head nor tail of it. I didn't realize that in effect it was like a box of chocolates that continued to give. I thought that's it. But in fact, there's another layer. In fact, I think there's even another layer. Yes. Right, here's the new quadrant fitted with all the gear train. And this gearbox is set in the A position and also position number 6. I'm all set up now to do some thread cutting. There's all sorts of ways you can do this, but I'm taking a very simple way, and I've also got a sample nut here, which is a commercially made nut of the same thread. So once this thing is machined to the point where this screws on nicely, that'll be adequate. That'll work nicely. It's possible to do it by calculation from the thread constants, but I'm just going to take a rough and ready approach to this, given that I have something that I know I need to comply with in terms of the thread geometry. So that's it. Let's get on with it. Right, that's threading on nicely. Well, I've just machined or set up now for the last of the machining items on this before I put a thread in the end of this. I'll do that by reversing things, but this is just a parting off operation. Well, there's the finished article. Little spigot on the end, just a little bit of 8mm, a stainless 8mm bolt that's been dealt with and threaded into the end of it. So that'll go in nicely. It'll take the place of the dipstick, and that'll work well. So there's only one other little issue relating to the gearbox I want to mention. Right, I'm nearly there. Just a few little issues to sort out. This cover won't go on because I need to take this nut off again and remove the nylock element of it. I'll just put that in the lathe. Then there's a few other things like the oil level plug and the drain plug, and indeed even this oil filler plug. This needs to be security wire drilled, and I'll sort that out, and then the gearbox is ready for fitting. Right, this is the end of video 6. All I can say is, if you're still with me looking at this, thank you for that. It'll be a little bit of time now until I get video number 7 underway, when I start taking the bike apart. So that's about it really. All I can say is, we live in a crazy world with all sorts of shenanigans going on in America with Mr. Trump, and this wretched virus rampaging through everyone's peace of mind. So all I can say is, personally, I'm glad to have my little workshop here where I can be productive in a very safe way. So for all of you who are out there in sheds, making stuff, making mistakes, doing it again, tread boldly, have fun, and I will produce another video just as soon as I can. For those of you who are still interested, thank you very much. Bye bye.